What's up, guys? Did my last video on paper cutting and edge geometry, and people were still confused. Not really confused, just it may be that people are using a different uh, definition of sharpness. And sharpness is a term that is kind of muddy in scientific terms. Some people say sharpness is how cleanly two angles meet at an apex. Some say it is sharpness is determined on how acute your angle is when cutting through material. Both are honestly correct, but if you want to get technical with it on a physics level and that kind of thing, sharpness is how cleanly two angles meet in space. And I'm going to talk about that later, but when people are talking about sharpness when cutting, of course, a 30-degree angle will slice through material better than a 60-degree angle. That all has to do with PSI. A 30-degree angle, so an angle which is very acute, will cut better than an angle that's very wide. That all has to do with PSI. This will put more PSI, pounds per square inch, on the material being cut through than this. That's all not debatable. That's true. This will still cut through material being dull better than this will if this was sharp. That all has to do with how acute this bevel is. That's true. More acute angles will cut through material better. More pounds per square inch, more material separation. It's less resistance after the cut has been initiated. Everything has it going for right here, the lower angle. The term sharpness that I was using is how cleanly two angles meet at an apex in space, which is this many degrees. When they meet in space, it is exactly 0 degrees. Whether you have this angle, which is 30, or this angle that's 60 in our, let's just call it 30 and 60. It doesn't matter what's up here because they both meet at 0, if that makes sense. If both are sharpened correctly, they will both still meet at 0 independent of what the angle is above the apex. So if you were to zoom up on this point and on this point at a high enough magnification, they would look almost exactly the same, if not exactly the same, because they meet at 0. It is not dependent on what's up here. It's all dependent on what's down here. How cleanly these two planes meet at 0. Actually, if you want to get further into it, this could not meet as cleanly as this, just dependent on how well it's sharpened. It is not dependent on the angle above it. It is kind of a hard concept to absorb. I know that. It's kind of a weird thing. It doesn't seem right, but it is. It's no matter what, if done correctly, this will always meet at 0. Always. If done correctly. I need to drive that home. If done correctly. Both of these will meet at 0, which means both of these can get just as sharp as one another if you're talking about how cleanly it meets at an apex. If you're talking about how smoothly it cuts through material, of course this is going to be sharper, as in it's going to feel like it cuts through material better. That doesn't technically mean it's sharper if you use the term literally, as in how cleanly the apex is done. One person cited that surgeons use obsidian blades. Well, yeah, those obsidian blades are very narrow. They break very narrow. They shatter very narrow like this. But that's not technically the reason they're used. Obsidian is technically a glass. Glasses don't have what's called cleavage. Their molecular structure is completely void of cleavage. When you shatter glass, it can apex itself all the way out to 0 on the molecular level, which steel can't do. The reason obsidian is sharper is not because of the super fine angles. it is because it is broken and fractured so cleanly that it meets out in space at 0, just like these do, so much finer than steel can due to its molecular structure. There is no cleavage for it to fracture and have irregularities on. It will literally break all the way out to molecules, nanometers thick at the apex, which steel cannot do. No matter how cleanly you try to meet either of these angles at 0, they can never, ever be as clean as obsidian due to their molecular structure, if that makes sense. So, sharpness is a term that a lot of people throw around that honestly I could be thinking of sharpness and you could be thinking of sharpness and have two different definitions in our head. So our thoughts won't jive. But if you talk about both and define them both, we can more clearly talk about it. It is interdependent, or not interdependent, it is independent of angle, how cleanly steel can meet at 0. Of course, if you have something that's nearly 180 like that's going to be hard to meet as cleanly as either of these. You will have a point of diminishing returns where you can't go so far out and still meet at a clean apex like this. I'm sure done correctly, you could still meet this at 0 cleanly, but I doubt you could ever get it like these two. But let's just call this 30 and 60. They both meet at 0 down on a microscopic level. One can be just as sharp as the other if you're using sharpness as a function of how cleanly the apex is done, how cleanly those two angles meet. If you're using sharpness of how easily it'll glide through material, of course, then 60 won't win on any level. But hope this clears some of that up. It's an interesting discussion regardless, but I don't want to draw this out. So thanks for watching, guys. I'll see you next time.